welcome back. What if in the condition when we purchase something in a large batch, in a large lot, and we got a discount for that? What kind of inventory model that could accommodate those situations? Let's discuss in this video.
Let's extend a bit about the economic order quantity model that we already discussed in the previous video with applying the quantity discount. In the previous model, we assumed that the AOQ model not accepting the quantity discount, but we can apply this model. We try to make a relaxation to this model and how we can implement this model with the situation when there is a quantity discount. But first, let's discuss about what we call it the reorder point. If AOQ model answering the how much, it means we determine the optimum Q, in this case, how much we should order. The reorder point tell us about when to order. These two information, these two variable, so we should find out in order to run the inventory. So the reorder point is equal to demand per day multiplied by the lead time. So this is the simple formula of the reorder point. So we see there's a demand per day, we simply write it down like small d multiplied by L, or lead time, representing the lead time. And then the small d itself, demand per day is equal demand in 1 year. So this is yearly demand. So this is yearly demand divided by number of working days in a year. When we take a look at the reorder point curve, so we see this red line. Red line is the amount of consumption per unit time of the inventory. And then this is the slope. We can calculate this one as a slope. This is unit per day, or small d in this case. And since we have the lead time, because the delivery and preparation to prepare our order takes time, takes about the L in this case. So we need to order beforehand. So when we should order is when our inventory level reaching this amount. So when we already reach this amount, so we should order. While we order, while our order is being processed and transport, we still consume, and exactly at the time when we need it, the order will arrive. Consider the example of the demand. The iPhone per year is 8,000, and in 1 year we have 250 working days. This is for simplicity. And lead time for order is 3 working days. So we can simply calculate the demand per day is equal to 8,000 divided by 250 is 33 units. And reorder point is 32 multiplied by 3, so is 96 unit. Means when our stock, our inventory level is reaching or touching the point of 96 units, so we should make an purchase order. Let's discuss further about the quantity discount model. Consider the following discount scheme. The discount number 1, when we order 0 to 999, there is no discount. We purchase with the price of $5. The number 2, if we buy with the quantity 1,000 to 1,999, we have 4% discount. So our price will be 4.8. And the third one, the discount scheme number 3, if we purchase 2,000 and over, we have 5% discount. So we will buy in the purchase price 4.75. How we can apply this discount price? So please take a look like this. In the quantity discount model, reduced price are often available when larger quantities are purchased. The trade-off is between the reduced product cost and increased holding cost. Yeah, this is common. When we purchase in large number, the holding cost will be increased. But if we buy in small number, we cannot get the reduction or the decrease of the product cost. Yeah. So this is the trade-off that we should solve. In this case, we calculate the total cost is equal to setup plus holding plus product cost. Yeah, in the previous one, in the economic order quantity model, we only consider the total cost as setup plus holding. In this case, we added more, that is purchasing cost of the product or product cost. So in here, the TC or total cost is equal to this formula. So there is an addition of product cost in here. The step-by-step in analyzing the quantity discount is as follows. For each quantity discount, we should calculate the Q. And then if the Q optimum, so this is the optimum of order, for discount doesn't qualify, choose the smallest possible order size to get the discount. So we have to make an adjustment to the smallest possible order size to get the discount. And then we should compute the total cost for each optimum order or adjusted value that is resulted from the step number 2. And then number 4, we have to select the Q, the optimal Q that give the lowest total cost. Take a look at this simple example. Okay, we have in the previous example, we have the structure like this. When we purchase an order is about 5,000, so D is equal to 5,000 in this case, and S is equal to 49. So D 5,000 and S is equal to 49, and then the holding cost in this case is equal to I, which is the fraction. This is kind of a fraction of the product price. We choose the fraction 0.2 or 20% of fraction, 20% of the product price as the holding cost. So based on the previous table that we already seen, we have the scheme number 1, scheme number 2, and scheme number 3. Scheme number 1, we don't have any discount, so we will purchase with the full price. This is $5. The second, we have a discount. Yeah, we have some discount, so the price will be 4.8. And then the third one, we have a further discount that our purchasing price will be 4.75. So we should calculate the Q for each scheme in this case. So we come up with this number 700, 714, and 718. If we consider one by one, yeah, the Q in this case, so 700, of course, 700 is in the area of region 1, because region 1 is purchasing until 90.99. So purchasing 1 to 999. So we can order 700. So this is applicable. But region 2, if we purchase 714, we cannot get the discount, because the discount, we will get the discount if we purchase 1,000 from 1,000 to 1,999. So 1999. So in this case like this, yeah. So we should adjust this number. So we eliminate this one and adjust to the closest one, to the closest and smallest one region where we can get the discount. So the closest one is 1000. So as we see it in here, so this is the first break is 1000 and then the second break is 2000, and the optimum for the second break is in here actually, but when we purchase in here, so the second price in here, the second price, we will not get a discount if we purchase here. So we need to adjust, yeah. So this is 714 is around here. So we need to adjust to the closest one that we can get the order. So this is 1000. Yeah. So we adjust to 1000. Region 3 is the region where we purchase 2000 or more. Yeah, above the 2000. So based on this calculation, we have 718. So this is not applicable. So we should adjust to the closest one, which is 2000. Okay. Based on this quantity order, so discount number 1, discount number 2, discount number 3, we get the quantity order 700, 1000, and 2000. We should calculate the total cost and result it with this total cost, and it turned out that the discount number 2 is having the lowest cost among others. So we should use the discount number 2, which means that we should order with the size of 1000. Yeah, and we got the price for 0.8 per unit. So that is all about the quantity discount. Yeah, let's continue again, enrich again this model with the probabilistic nature of demand and lead time in the next video. See you again in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.